Hello friends, welcome to this video on circles. In the previous video, we discussed angles subtended by a chord at a point. Today, we will learn about the perpendicular from the center to a chord. Let's start with an activity. Draw a circle with radius 4 cm and O as its center. And draw a chord PQ in it. Friends, with the help of scissors, cut the circle. Now, fold this circular paper in half so that one part of it covers the other part completely. Now, open it like this. From the center of the fold, draw a line on the chord. Let's call the point at which this line intersects chord PQ as point T. Now, with the help of a protractor, find the measurement of these angles. Friends, you can see that the measure of these angles is 90 degrees. That is, they are right angles. Now, we can say that line segment OT is perpendicular to chord PQ. Friends, here, T is the midpoint of chord PQ. You can pause the video and check it. Friends, you can see that the length of these two segments are equal. That is, line segment OT perpendicularly bisects chord PQ. Friends, you can repeat this activity by making more circles. You will find that a perpendicular drawn from the center of a circle to a chord bisects the chord. This is a theorem. Come on, let's prove it mathematically. With the help of the statement, draw a figure. We are given that OD is perpendicular to chord AB and we have to prove that line segments AD and BD are equal. If we join OA and OB in this way, we will get two triangles ODA and ODB. And if we prove these two triangles are congruent, then we will get these sides as equal. Friends, in triangle ODA and triangle ODB, angle ODA and angle ODB are right angles because we are given that OD is perpendicular to AB and the hypotenuse OA and OB of these two triangles are the radii of this circle, so they will also be equal. Friends, you can see that OD is the common side. Therefore, these two triangles are congruent according to the right angle hypotenuse side or RHS congruence rule. We know that corresponding parts of congruent triangles are equal. Therefore, the corresponding sides of these triangles, side DA and side DB, will be equal. That means AD is equal to BD. Thus, we proved that a perpendicular from the center of the circle to a chord bisects the chord. Friends, will the converse of this theorem also be true? That is, if we say a line drawn through the center of a circle to bisect a chord is perpendicular to the chord, will this statement be true? Absolutely. Let's see. Draw a circle. Suppose its center is O, in which a chord SR is drawn. A line from the center O to the point N is drawn in such a way that it divides the chord into two equal parts. This means here SN and RN are equal, and this is given to us. We have to prove that line segment ON is perpendicular to side SR. Friends, for this we have to prove that angle ONS and angle ONR measure 90 degrees. How will you prove this? You can pause the video and think. Friends, if we join these 2 points with the center, we will get two triangles, triangle ONR and triangle ONS. Can we prove them to be congruent? Yes. Pause the video and do it yourself. Friends, you will find that these two triangles are congruent according to the side-side-side criteria or the SSS congruence rule. And we know that the corresponding parts of congruent triangles are equal. Therefore, angle ONS and angle ONR will be equal. We have to prove that angle ONR and angle ONS are right angles. Look at the figure carefully. Angle SNR is a straight angle. Therefore, it will be equal to 180 degrees. And angle SNR is formed by joining both these angles, and both are also equal. Therefore, we can say that both these angles are right angles, that is, of 90 degrees. Therefore, the segment ON will be perpendicular to chord SR. This statement is true. In this way, we also proved the converse of this theorem, that a line drawn through the center of the circle to bisect a chord is perpendicular to the chord. Friends, that's all in this session. Today, we studied about perpendicular from the center to a chord. See you in the next video with some questions related to this. Thank you.